This is Unit 6.2, Applications of Vertex Form. So now that we have the equation in vertex form, which is y equals ax minus h squared plus k, this one right here, and vertex form clearly tells us what the vertex is. So the blue graph here, if it's opening up, then this would be the vertex at hk. And the k value, if this is the y-axis right here, whoops, that was not very good. If that was the y-axis, then this value right here, the y-coordinate of this point right here, that k value, that would be the minimum value of the relationship between x and y. And if it's like the red graph where it opens down and this is your y-coordinate of your vertex, that would be the maximum value of the quadratic relation. So there's a lot of things in real life that actually follow a parabolic curve. For instance, the height of a ball, if you were to drop it, or a height of anything, if you were to drop it, its actual height off the ground, it's just falling straight down. Its height over time actually is a parabolic relationship. Or even if you take a ball and you throw it straight up in the air and then you let it fall, that the relationship between height of that particular ball and time is also parabolic, because there's a maximum height that that ball is going to reach, and as it gets higher and higher and higher, it goes up at a slower rate until it stops rising, at which point it's hitting its peak, and then it starts to fall again, and as it keeps falling, it falls faster and faster and faster. So it's not actually, when you drop a ball, the relationship is not linear. It actually turns out to be parabolic. So we're going to do example number 1 here. So the path of a soccer ball is modeled by the relation h equals negative 1/16 d minus 28 squared plus 49, where d is the horizontal distance in meters. So I'm just going to draw a quick little diagram of what this looks like. There we have a vertex at the point 28, 49. So if this is 28 and this is 49, we have a maximum value here. The fact that this is negative means that it opens down, which means that this value here, the y-coordinate of the vertex, so the vertex is at 28, 49, this y-coordinate of the vertex is going to be a maximum. Now, the a value is negative, which means it opened down, but it's also 1/16, which is really, really, really wide, right? It does something like this, and then eventually I'm guessing that the soccer ball comes down. Now, I don't know, in order to find the y-intercept, so the y-intercept, we'd let d equals 0. So this is distance. So the soccer ball gets kicked or something. Maybe it's kicked somewhere in the air, and this is the height of the soccer ball. And so if we let d equal 0, then the h is going to be negative 1/16 0 minus 28 squared plus 49. And so h equals negative 1/16 times negative 28 squared plus 49. And I'm not sure where my calculator is. Not sure, so I'm going to do this. I'm going to go into education, and nope, that's not the one I want. I want math. And here's my scientific calculator through Desmos. So negative 1 divided by 16 times, whoops, bring that back, times 28 squared and plus 49. Oh, it is 0. Okay, all right. good to know. So that means then this ball actually doesn't quite do what I said what I drew. It actually, since it starts at height of 0, it does this. Okay, does something like this. It's symmetric. All right, so sketch the path of the soccer ball. What is the maximum height? So this is A, this is B. The max height equals 49 meters. What is the horizontal distance when this occurs? Occurs 28 meters from where it is kicked. That's the horizontal distance. What is the height of the ball at a horizontal distance of 20 meters? So when it's about 20 meters right here, the question is, what's the height? Well then, for that one, we want to let the horizontal distance equal 20. So h equals negative 1/16 of 20 minus 28 squared plus 49 equals negative 1/16. That'll be negative 8 squared plus 49. So negative 1/16 times 64 plus 49. And so negative 1/16 times 64, that's going to be negative 4 plus 49, and that equals 45 meters. So therefore the ball is 49 meters high when it is 45 meters from where it is kicked. And find another horizontal distance where the height is the same as in part D. Well, since the parabola is symmetric, that means that the distance on this side, which is 8 units, is going to be the same on this side. So remember, this is your axis of symmetry right here. The parabola looks the same on both sides of that axis. So 28 plus 8 equals 36. So E, when the ball is 36 meters horizontally from where it is kicked, it will be 45 meters high. Okay? All right, let's take a look at the next example. A golf ball is hit with a trajectory following a vertical height of, so this is height over time, where h is the height of the ball and t is the time in seconds. So now, instead of my horizontal axis being distance away from where it's kicked, now this is the height of the ball over time. And how long is the ball in the air for? So h, that means we want h to equal, so it's going to start somewhere. So at time t equals 0, okay, so this is t equals 0. That's negative 5 times negative 2.25 squared plus 26.5. So let's just take a look at, so let's clear this. So negative 5 times 2.25 squared, and then plus 26.5. Do I have my numbers right? I think so. 1.1875. Let me just see. Yep. So it actually is hit at a height, according to this, it seems awfully weird. it's hit at a height of, or at time 0, it's actually 1.1875 meters off the ground. That doesn't mean that's where it's hit, that's just where it is at time 0. So 1.1875 is here. After 2.25 seconds, it reaches a maximum value of 26.5, and then at some point it's going to hit the ground. So from here to here, we can't say this over here is another 2.25, because if we consider this our axis of symmetry, we have to be at the same height another 2.25 later. So another 2.25 later, it's still going to be 1.1875 meters off the ground. So that's going to be at 4.5, but at some point it's going to hit the ground. That's 1.1875. So how long is it in the air? It's in the air until it hits the ground again. So it's in the air until h equals 0, which means that 0 equals -5 times t minus 2.25 squared plus 26.5. Okay? How long is the ball in the air? We need to find t when h equals 0. So bring the 26.25 over to the other side. 26.5, sorry, that'll be negative on this side. Okay, so we're trying to solve for t. We got to work backwards. So we got to start with the stuff that's furthest away from the t, outside the bracket. We have to isolate this bracket here. So to isolate that bracket, we've got to get rid of the addition and subtraction first, and then we can get rid of the division or the multiplication through division. So 26.5 divided by 5, that's going to be 5.3. So that equals t minus 2.25 squared. Now we need to undo the squaring, and to undo squaring, use square root. You can't add the 2.25 yet because it's still inside that bracket. And you've got to isolate the bracket, and the bracket's not quite isolated yet until we get rid of that squaring. So we're going to square root both sides. I need to calculate the square root of 5.53. So square root of so just 5.3. That's 2.302. All right, so 2.302. Square rooting the square gets rid of the, and this is actually it's actually plus or minus on this side. And that's because originally, okay, so let's take a look at this. Let's suppose 9 equals x squared. And to solve that, if we square root both sides, you're going to get that x equals 3. But the original question wasn't, what's the square root of 9? The original question was, what can I square to get 9? So I can square 3, or I can square -3. So when you do that answer, when you do that square rooting, the answer that you get on the left-hand side has to be positive or negative. And there's technically two answers to this. I want to know, when is this going to equal 0? And if I extend this parabola back here, it's going to equal 0 at that point there, and it's going to equal 0 at this point here. Now for this particular problem, time can't be negative, so that doesn't matter. This answer back here, it doesn't matter. It's just this answer up here that's going to matter. So I get two situations here. I get that either, let me go to red, either 2.302 equals t minus 2.25. So I bring the 2.25 over to the other side, and that's going to give me 4.552, or negative 2.302 equals t minus 2.25. And when I bring that over to the other side, that's going to be a positive on the other side, so it actually becomes negative 0.052. So this answer back here on this side of, so this answer here, that is happening at negative 0.052 on the horizontal axis, and this answer up here is happening at 4.552. So that means, so therefore the ball is in the air for 4.552 seconds. All right. Example number 3, a design engineer builds an arch. He uses the equation h equals negative d squared plus 16, where h is the height in meters and d is the horizontal distance in meters from the center of the arch. A banner is to be placed on this arch to celebrate the Newtonville Fair. If the banner is placed at a height of 12 meters, how wide should the banner be? So basically we have a parabola. The vertex of this parabola, there is no left or right because there's nothing inside the bracket here. There's no left or right shift, but there is an up and down shift, so the vertex is at 0, 16. So we've got up here at 16, that's where the vertex is, and so the arch does something like this. We know that A is negative, A equals negative 1, so it opens down. All right, so this is what it's going to look like. It's going to be symmetric on either side, so please forgive me that this doesn't look perfect. But this number here on the horizontal axis is going to be the same as that number there, only vertical, or sorry, only negative. So we've got D is on the horizontal axis and H is on the vertical axis. Now before I do anything, I want to know what these numbers here are going to be. So that's when H equals 0. So H equals negative D squared plus 16. So 0, again, these are the x-intercepts, right? This is where it's crossing the x-axis. That's when H equals 0. Minus D squared plus 16, bring the 16 over, sorry, bring the D squared over, so D squared equals 16, and square root both sides, D is going to equal plus or minus 4. So this will be at minus 4, and this will be at positive 4. So this arch, or arc, is 8 meters wide. All right, now, a banner is to be placed in this arc to celebrate the Newtonville Fair. If the banner is placed at a height of 12 meters, how wide should it be? So the height is 12. We're putting this banner up. The question is, what are these variables here? So that means that H equals 12. So 12 equals minus D squared plus 16. Bring the D squared over to the left side and bring the 12 over to the other side. So that's 16 minus 12, which is 4. So D equals plus or minus 2. So then the banner, this will be minus 2 and positive 2, which is a total width of 4 meters. So therefore, the banner should be 4 meters wide. I can't express to you how important it is to draw a diagram. And again, you know, try to be as accurate as you can. It doesn't have to be perfect. Mine aren't perfect by any stretch of the imagination, but they do show what's going on, and a picture is worth 1,000 words. Using your equation, draw a diagram and make it as detailed as you can possibly make it. Okay, now example 4. The cost per laptop, C, so C is cost, can be represented by the equation C equals 0.1 x minus 100 squared plus 200, where x is the number of laptops produced. To make a profit, the cost per laptop must be less than $400. How many laptops should be produced to accomplish this? So 400 is right here. So we can't have a cost less than that. Sorry, we can't have, we have to have, the cost per laptop must be less than $400. So the cost per laptop has to be somewhere, the number of laptops has to be somewhere between here and here, because we need a cost that's less than 400. All right, so we need to figure out where is this happening. Now it looks like from the graph that this is around 55, and that on this side it's around 145 is what it looks like. But we're going to do this algebraically as well. So we've got C equals 0.1 x minus 100 squared plus 200. We want C to equal $400. So substitute the 400 into the equation for C and solve. So the first thing we need to do is isolate this bracket with the squaring. So we've got to get rid of the 200 first. So 400 minus 200 equals 0.1 times x minus 100 squared. So that's going to be 200. Okay, we're still trying to isolate this, which means we've got to divide both sides by 0.1. So that's 2,000 equals x minus 100 squared. Now we need to isolate the stuff that's inside the bracket. So we've got to isolate this, which means you need to get rid of the squaring. So we need to square root both sides. And my handy dandy calculator, what is the square root of 2,000? It's 44.72. So, and that's plus or minus 44.72 equals x minus 100. So we get two answers here. So 44.72 equals x minus 100, or negative 44.72 equals x minus 100. Add 100 to both sides, add 100 to both sides. So add 100 to get rid of that. So that's 144.72, which rounds to about 145, which is exactly what we thought on the graph. And then for this one, add 100 to both sides again, and x is going to be 55.28, and that rounds to about 55. So 145. So we need between, so therefore between 55 and 145 laptops must be produced. Okay, and again, just the equation, we knew that the vertex was at 100, 200. right there. And again, a picture is worth 1,000 words. This is your homework for this unit. It is posted on D2L. And as usual, please see me if you are not see me. Please contact me if you have any questions.